Hi, I'm Başak, and welcome to my presentation. You see another name on the slide, which is Emre. That's my official name, but I want to be called Başak and prefer to be addressed with she and her pronouns. I'm a PhD candidate at Visualization and Graphics Group at Utrecht University. After this brief introduction about myself, let's continue with our research. Well, we live in a world teeming with complex decisions, whether it's in healthcare, technology, or environmental policy. Information can be overwhelming and options seem endless. Imagine having a guiding compass that not only helps you navigate the exploration of decision space, but also empowers you to design alternative solutions and confidently make choices. Today, I will present a critical investigation of visualization tools regarding their support for decision making. Next, let's talk about where and how we found visualization tools. We searched through several visualization venues and digital libraries to find articles which depict a visualization tool and includes keyword decision in their abstracts or titles without restricting the year. This initial exploration turned out a limited collection of 88 articles, each discussing a visualization tool in the context of decision making. Later, we narrowed down our search by honing in on articles where the authors explicitly emphasize their tool's support for decision making. But to what extent these 60 visualization tools support decision making? We analyzed all these 60 tools to identify their support for distinct decision making stages, to find decision focused visualization tools for further investigation. But what is a decision focused visualization tool? Let's start with understanding how we make decisions. We adapted 3 distinct stages of decision making by Herbert Simon to better understand the unique features of decision tasks in a visualization. The intelligence is the starting point, where decision makers act as information detectives, sifting through data to uncover the essentials and ignoring the noise. It's like putting together a puzzle, one piece at a time. Moving on to the design stage, the scene shifts to creativity. Decision makers become architects of options, simplifying complex information into manageable chunks. It's a bit like sorting things into different boxes to make sense of them. Finally, we arrive at choice stage, the climax of the process. Decision makers weigh their options, considering pros and cons, before making a well-informed decision. These 3 stages provide a roadmap for decision making, and that's where our story intersects with the world of visualization. We have learned about different stages of decision making. Now, let's continue with understanding the essence of decision-focused visualization tools. At its core, a decision-focused visualization tool must fulfill a crucial requirement of supporting at least choice stage of decision making, because a decision making at its minimum requires a choice between 2 alternatives. But still, supporting intelligence and design stages can further facilitate more complex decisions, including more alternatives and multiple criteria. Based on this minimal requirement of having at least support for choice stage, we identify 27 decision-focused visualization tools among 60 tools. Next, we further investigated these 27 decision-focused visualization tools for their support for decision making by using 2 metrics, flexibility and visibility of decision elements, which are alternatives, criteria, and preferences. To better understand what is an alternative, criteria, and preferences, let's look at an example. Assume there is a city planner who wants to solve the transportation issue of the city. There can be some alternative solutions, such as building a new highway or improving the public transport. To pit one alternative against another, the city planner can consider several factors, such as environmental impact, cost, and traffic congestion. Those are the criteria of the decision problem. Yet, the city planner can emphasize some criteria over the others. For example, in this figure, you can see that the city planner preferred the environmental impact more over the other criteria. After the clarification of alternatives, criteria, and preferences, let's continue how we defined flexibility and visibility. With flexibility, we considered the degree of interactivity offered by a visualization tool. The interactivity classified into two categories, which are data interactions versus non-data interaction. Because our focus is on data comprising alternatives, criteria, and preferences, we used data interactions, which are presentation, processing, mapping, and input. Among them, the presentation interactions allow a decision maker to alter the presentation of decision elements via the features such as highlighting, filtering, and zooming. Processing level interactions enable a decision maker to manipulate functions over decision elements. For example, modifying a model or its parameters that calculates preference values. Mapping interactions utilize a decision maker with the ability of changing the visual representation of decision elements. For example, a decision maker can switch between the tabular representation of a decision criterion as a column versus a more sophisticated radar chart representation of the same criterion on the axis of the chart. Finally, input interactions empower a decision maker by allowing her to integrate her own knowledge into the visualization. For example, by editing or adding a new criterion which does not exist in the current dataset. On the other side, we considered visibility as the transparency of each decision element, alternatives, criteria, and preferences. Additionally, we also tagged each tool to identify if the depicted solution is domain general or specific, if there is a support for multi-criteria decision making, if the tool offers a dimensionality reduction or data aggregation technique, and finally, if there is a guidance for artificial intelligence or machine learning algorithms during the process of decision making. Now, let's see what we found regarding the decision support of decision-focused visualization tools at different stages of decision making, considering our metrics and tags. Let's start with discussing results regarding the three different stages of decision making. By definition, all of 27 decision-focused visualization tools supported the choice stage. Similarly, we also observed all of those tools supported the intelligence stage by enabling decision makers to explore the decision space. However, in contrast to intelligence and choice stages, we observed that only 11 of 27 decision-focused visualization tools helped with design stage, which is crucial for crafting and refining decision alternatives. Now, let's continue with observations on how visible decision alternatives, criteria, and preferences. Most of the tools showed decision alternatives and criteria visibly, but decision preferences were neither much visible nor flexible at different levels of interaction. While a remarkable amount of decision-focused visualization tools covered presentation and mapping level interactions, deeper analysis on mapping interactions revealed an interesting fact that I will discuss later. We also observed almost no support for interaction at processing level. Additionally, there was also lack of support for integrating decision makers' own knowledge about decision elements into visualization tool via input interaction. Regarding the results related to our text, the current status of decision-focused visualization tools pointed out elevated developments in AI technologies have not yet been well integrated into visualization tools. While majority of the tools support multi-criteria decision-making, most of the tools aimed support for a domain-specific problem. Here, you see domain-specific tools in white. And finally, only a few tools used dimensionality reduction or data aggregation technique. Next, let's discuss what we learned from identifying gaps and what implications and opportunities exist for future decision-focused visualization design. First of all, it was surprising to find a number of decision-focused visualization tools comparable to number of visualization tools in more specialized and recent topics such as Bitcoin. This tells us that there is an opportunity to designing and implementing more decision-focused visualization tools, while it seems this research area is underaddressed. As I previously showed in my slides, most of the decision-focused visualization tools covered mapping level interaction. But we also observed that qualitatively, those interactions were limited to what predetermined by designers. However, a recent survey with decision makers highlights the difference in their mental models. Thus, a decision-focused visualization tools should implement more flexible data interfaces in which decision makers can sketch freely and create data representations that fit with their mental models. We also observed most of the tools did not involve decision makers early in their design process, as previous research showed the distinct needs and goals of different user profiles. A featured decision-focused visualization tools designers should integrate decision makers early in their design process to utilize their goals, expertise, and visualization proficiency to implement a visualization tool that satisfies each individual needs. Finally, I would like to thank the co-authors of the paper, Ria, Michel, Narges, and Evanthia, the authors of 27 decision-focused visualization tools, for swiftly and kindly providing their own figures, Mahmut Jazm for his precious feedback on manuscript, and finally all of you for listening my presentation. Thank you.